Okay, today we're going to explain hydrohalogenation of alkenes. You got your alkene, you get your hydrogen bonded to a halogen, and then you're going to get a halogen and a hydrogen next to it. We're going to remember that this is a Markovnikov addition. That means that the carbon with the most hydrogens is the one that's going to get the hydrogen, and the carbon adjacent to it is the one that's going to get the halogen. So this is the generic formula: RCH double bond CH R prime. Then we know that the double bond has a high electron density, and we remember from general chemistry that this bond right here is a polarized bond, because group 7A is going to be pooling electrons, and it's going to be more electronegative. Thus, it's going to make the electron density in this hydrogen really low. So this is going to be a partial positive, and this is going to be a partial negative. So obviously, the electrons are going to want to attack the partial positive atom. So it happens this way. Then we make an addition here, and this carbon only has 4 bonds. It's bonded here, 1, 2, and 3 to the hydrogen. So it has an empty orbital. That empty orbital, since it doesn't have any electrons, we're going to represent it with a positive charge. That means that this is a carbocation. And then we have plus the X minus. The electrons went to the X, and we have X minus right there. Then we got to remember also that X is going to be your atoms from group 7A, the halogens. We have Cl, Br, F, I. This X can be any of this. So moving along, we go to step 2. In step 2, in mechanisms, we're going to copy exactly what we have there as products, and we're going to place it as reactants on this side of the equation. So we copy the carbocation and the H plus the X minus, and then it went to here. The X minus that has 2 electrons is going to attack the H plus, the carbocation, and it's going to add to that carbon right there. So let me explain the mechanism for this. We copy this. CH, double bond CH2, plus H, let me show the bond between Br, they're sharing electrons. And how is this going to work? We know that this bond is polarized. Again, there is electrons going that way. So this is going to be partial positive, and this is going to be partial negative. You do not need to show this on your mechanism. I'm just explaining why this region, this bond, is going to attack this hydrogen. It's going to attack it because it's a partial positive. It cannot go to the partial negative because it's going to be negative and negative. They repel each other. So once you have it there, then you're going to find that you have a problem. The problem is going to be that you don't know what carbon took the hydrogen. So we remember Markovnikov. We said that since this one has 2 hydrogens, this one has only 1, then this one's going to take the hydrogen. What do we say? That this has an empty orbital. This one took the electrons to break the bond. And we have the positive charge, fully positive charge right here, carbocation, secondary carbocation. So it's going to be somewhat stable, plus Br minus. So then step 3, we're going to take exactly what's on the other side. So we're going to say CH3, CH2, CH, CH2 in the hydrogen right here, plus the Br minus. We know that this is going to be a carbocation, and we know that negative and positive attract, so this is going to attack this one, and you're going to get this molecule, CH3, CH2, CH, CH2, the H right here, and the Br right here. Now, the way I'm going to write this is going to be, I'm going to take this H out, and I'm going to write it as CH3. Let me give you another example of hydrohalogenation of alkenes. We got our alkene molecule right here, and we have a hydrogen attached to a halogen. Okay, the expected result for this would be CH3, Cl, CH3, CH2, CH3. What happened here was a 1,2 hydrate shift. Let me show you the mechanism for this reaction. We copy this side, so we have CH3, CH, CH3, CH double bond, CH2, plus H, Cl. Okay, so let me show this hydrogen up here. So we know Markovnikov tells us this is going to attack the partial positive hydrogen, and it's going to go to the carbon that has the most hydrogens. So let's see how that looks. CH3, C, H up there, CH3 here, CH, CH2. And the hydrogen attaches to the one that has 2, not the one that has 1. Now we know this is going to be a carbocation. Now we're going to get into the stability of carbocations. Carbocations, this is a secondary carbocation, it's in a secondary carbon, so it's somewhat stable. It's better than primary. But right next to it, it's a better carbocation because it's a tertiary. It has 1, 2, 3 carbon groups attached to it, so it would make a more stable carbocation. So what's going to happen is we have that right there. And what's going to happen is this hydride, we got to remember that hydride is the hydrogen with the 2 electrons. We have a proton, which is an H without any electrons, and we have hydrogen, which is H with 1 electron, 1 proton. They cancel each other. The charge on this is 0. So we're moving the hydride, that means both electrons, they go here to this carbon. So the charge, the empty orbital, is going to be on this one now. And this is going to be plus the Cl minus. I forgot to do this, sorry. So we got Cl minus right here. And we are going to get CH3, C, the empty orbital right here, CH3, CH. Then I'm going to show this hydride up here so you can see it better, and the CH3 right here. So we have that plus the Cl minus. Now the last step for this addition is going to be the CH3. We're going to copy that right there. C, CH3, CH. Let me write the H as H2 and CH3 plus the Cl minus. Now we know that minus is going to attack the plus. It's going to stabilize that. And we are going to get this molecule up here. We're going to get CH3, C, the Cl, CH3, CH2, and CH3. Okay, now I'm going to teach you another addition. This is going to be a 1,2 methyl shift. And the product of this reaction is going to look something like this. I Now, let me show you how we arrived at that. The mechanism for this is going to look like this. We're going to copy this again. It's going to be the same exact thing. Plus the HI. I'm showing the bond. Now, we know this is partial positive, partial negative. This is going to attack the partial positive, and this is going to leave, taking the electrons with it. And what we get is this hydrogen is going to attach to the one that has the maximum number of hydrogens right here. And then this one's going to be a carbocation, and we have an H here. So then, this is a secondary carbocation. Right next to it, there's an opportunity for a tertiary carbocation. So it's going to be the same exact thing. This is going to move here to stabilize the carbocation, making it a tertiary carbocation. That step is going to happen really fast. So we copy that right there. And then we know that either one of the methyls is going to move to stabilize that charge. So the product of this is going to be then we're going to have our carbocation is going to be located right here on this carbon, C. Then the methyl that migrated is going to be right here. Then we have an H and CH3. This is going to be plus the I minus. And then we can imagine what's going to happen in the last step. We copy the reactant side. Now we know that the minus charge is going to attack the plus charge. And what we're going to get is this.